That's a big key for secant. When you graph secant, you'll want to type in 1 over cosine. And when you graph secant, and same thing with cosecant, you get a series of n's and u's. And each of those will count as a period for secant. Okay, so that's what we have. If you go to your table, you're going to see some error messages, and those error messages will be real. Those will be asymptotes. So 90 degrees will be an asymptote. 0 is going to give me a 1. If we go another 90 up to 180, you're going to get a negative 1. And then if you go to 270, you'll get another error message. So that is an asymptote. So we have us an asymptote here. And somewhere in between, I think it would be about right there, is 270. Those will be asymptotes. Nice point here, this 1. Low point, nice point here, negative 1, high point. Let's fill in the table. Let's get rid of that. All right, we're going to be reciprocating cosine. When we reciprocate for like the cosine of pi over 6, cosine of pi over 6 is radical 3 over 2. So when we reciprocate it, we get that. And that'll rationalize to this right here. When we reciprocate for the cosine of pi over 4, we get radical 2 over 2. So when we reciprocate, we get this. And that cleans up pretty nice. The cosine of pi over 3 is a half. So when we reciprocate, and that's really nice. Okay, 0, cosine of 0 is 1, reciprocate 1, you get 1. Cosine of pi over 2 is 0, reciprocate 0, that's why that's an asymptote. Okay, so we have this lovely point at 60, we have another lovely point, and then we have us an asymptote. Okay, over here. 30, 60, let's keep going. 120, this is your second quadrant. Cosine is negative, so this will be negative 2. And we'll be maxing out. And then we fall again, 210, you're in the third quadrant, so cosine stays negative. Asymptote. 300, now you're in the fourth quadrant, so things are positive for cosine. And then we get us a 1. And we'll move this one over here. Okay, so a few more points. This 60 here will reflect over here because cosine is an even function. Put that in the wrong spot. Cosine is an even function. That means it has y-axis symmetry. And I can reflect that asymptote over here. Okay, moving to the right. 30, 60, 90, I can come down here to negative 1. 30, 60, 90, I have another asymptote. And then you'll continue with that. Beside the asymptotes, here is a negative 2. Here is a negative 2. And this is what secant looks like. A little pointy. Little pointy. If you were to graph cosine, let me show you that. Different color. Ooh. It would look like this right here. So where this cosine maxes out right here, secant bottoms. And where cosine bottoms out, secant tops out. Nice color. Let's answer some of these questions. Let's see, how do I do that? Oop. I can't figure it out. Why does this thing hate me so much? All right, some nice points. 0 was a nice point. Pi is a nice point. And if you keep going, every pi from there will be nice points. And they'll just alternate back and forth from 1 to negative 1. Pi over 2 was nice, but it really wasn't a point. It was an asymptote. So that's going to help us with our domain. All real, but pi over 2 plus minus. And 3 pi over 2 was helpful, again, but it was an asymptote. And those are pi apart, 180 degrees apart. K pi. What else was nice? Cosine loves the 60s, so pi over 3 was nice. That gave me a 2. 2 pi over 3 was nice. Second quadrant, negative 2. 4 pi over 2 was nice. That gave me a negative 2. And 5 pi over, did I say over 2? 4 pi over 3 was nice. That's going to be negative 2. And 5 pi over 3 would be nice. Would also be a positive 2 because fourth quadrant. The range, a little weird. You start low and then you go to negative 1 and then you get there. But then there's a gap and it picks up on 1 and then goes to infinity. The period of this graph, just like cosine, the period will be 2 pi divided by any b value. And since it was y is equal to secant 1x, your b value is a 1, so the period is 2 pi. The intercepts, we didn't have any x-intercepts. And we did have a very nice y-intercept at 0, 1. Roll this down a little bit. And for the asymptotes, they're vertical lines, so x is equal to. And this domain thing will help you with your asymptotes. Nice.